we're going to talk about analyzing graphs specifically of quadratic functions. So let's take a moment to graph the function y equals 2x squared minus x minus 4 and identify some of the following: the vertex, the axis of symmetry, whether this is a maximum or minimum value, domain, range, and when it's increasing and decreasing, to kind of bring together some of the things we've already been talking about in class. So I'm going to switch over to Desmos. And in here, I'm going to graph 2x squared minus x minus 4. Here I'm given some pieces of information. I'm given the vertex, which is 0.25 and negative 4.125. The axis of symmetry is going to be x equals the x value of our vertex. When I plot this point, you'll see that it goes right through the vertex, and if I were to mirror from left to right, my parabola certainly mirrors over that value. This is also the minimum value of 0.25 and negative 4.125. We'll see that with parabolas and quadratics, that it's either going to be the minimum value or the maximum value. Our domain is all real numbers because our parabola will continue opening up from left to right forever and ever. Our range is slightly different. Our range, notice, will start at negative 4.12, our y value down at the bottom, and will continue up forever and ever. So our range is from negative 4.12 inclusive through infinity. We are increasing from 0.25 to infinity on the right-hand side of our graph, and we are decreasing from negative infinity to 0.25. So our vertex was at 0.25, negative 4.125. Our axis of symmetry was x equals the x value. The vertex itself was its minimum value. Our domain was all real numbers. Our range started at negative 4.125 because, again, our range is the y values through infinity. And since our graph looks something along these lines here, we were decreasing from negative infinity to 0.25. At the vertex, we switched, and from 0.25 to infinity, we were increasing. And notice that our value, our a value, was positive, so we are a smiley face with our parabola. The next equation is negative 3x squared plus 6x minus 2. Notice that we have a negative value, so that means we're going to have a frowny face. Our vertex here, I'll let you have the opportunity to graph this using Desmos. But our graph is at 1, 1 is the vertex. And since we know it's going to be frowny face, it's going to go something like this. Our vertex is 1, 1. Therefore, our axis of symmetry, which we know goes through the through the x value, is x equals 1. This is a maximum value since the highest point is the vertex itself. Even though it's upside down, our domain will still be from 1 to infinity, negative infinity to negative infinity. Our range will be different because notice the highest point we go is at positive 1, but everything below is included. So our range is from negative infinity on the y-axis through positive 1. And positive 1 is included. This time we're increasing on the left, and when we hit that vertex, we turn to decreasing. So we're increasing from negative infinity to 1, and then from 1 to infinity, we are decreasing. So a lot of things are playing on this vertex. A lot of the descriptive things are playing on the vertex. So let's talk about the vertex itself. We can find the vertex by when our equation is written in ax squared plus bx plus c. When we take opposite of b over 2a, we can find our x value, then plug that x value into the function to identify what that y value is of the vertex. Here we have the equation x squared plus 10x plus 23. Let's find the vertex, the axis of symmetry, and the maximum or minimum value. Our a value is 1 and our b value is 10. We don't need c in this particular piece of the equation. So we have the opposite of b, which is negative 10, and this is helping us find x, over 2 times our a value. When simplified, gives us negative 5. So far we know that negative 5 is our x value. We now need to find our y value. So I will plug into my function f of negative 5. So negative 5 squared plus 10 times negative 5 plus 23. This gives us 25 minus 50 plus 23. Simplifying gives us negative 2. So our vertex is at negative 5, negative 2. The value in front of x squared is positive, so we know we're going to have a smiley face in this direction. We also know that our axis of symmetry goes right through the x value. So our axis of symmetry is x equals negative 5. And because it is a smiley face, the smallest value, or our minimum value, is also negative 5 and negative 2. And you can use Desmos to graph. Let's try another example. Here we have g of x is x squared over 2 minus 4x plus 8. We're supposed to find the vertex, the axis of symmetry, and the min or maximum value. Our a value is half, and our b value is negative 4. So finding x, I need the opposite of negative 4, which is positive 4, over 2 times our a value. This then gives us 4 over 1, or simply 4. So I know that 4 is my x value. We can plug in f of 4 into the equation. Four squared is 16 over 2 minus 16 plus 8. 16 over 2 is 8. 8 minus 16 is negative 8 plus 8, so 0. So our vertex is at 4, 0. Notice this is a positive, so we'll have a smiley face somehow. And I'll let you use Desmos to continue graphing to find more exact points. But we know that our axis of symmetry goes right through that vertex. So our axis of symmetry is x equals 4. And this is a minimum value. Here we have negative 2x squared plus 10x minus 23 halves. Let's find the vertex. So our a value is negative 2. Our b value is 10. So x is opposite of b, so negative 10 over 2 times our a value. This gives us negative 10 over negative 4, which simplifies to 5 halves. So we know that 5 halves is the x value. We can now substitute in 5 halves into the equation. So negative 2 times 5 halves squared plus 10 times 5 halves minus 23 halves. Negative 2 times 25 fourths plus 10 times 5 halves minus 23 halves. This gives us negative 50 fourths, or realistically, we should keep this as negative 25 halves, since these can simplify, plus 50 halves minus 23 halves. Gives us, well, negative 25 plus 50 is positive 25, minus 23 is 2 halves, or 1. Our vertex then is 2.5, 1. Notice we have a negative value, so we'll have a frowny face. Since it's a frowny face, this is our maximum value, so our maximum value is 1 when x is 5 halves. We have our axis of symmetry here, and our axis of symmetry is still x equals 5 halves. Without graphing then, let's see if we can put some information together based on what we know a graph looks like. We have f of x is negative x squared plus 14x minus 47. So let's start off by finding the vertex, since this helps us find everything. Our a value is negative 1 and our b value is 14. So then our x value is opposite of b, so opposite of 14 over 2 times a. This gives us positive 7. Now we can find our y value by substituting in 7. So negative 7 squared plus 14 times 7 minus 47. This is negative 49 plus 98 minus 47. Simplified gives us 2. So now I know that my vertex is 7, 2. Thinking about our vertex and knowing that this is a negative, we're going to have a frowny face. So this point here will be 7, 2. We can get an idea of what it might look like. Because it's a frowny face, then we know that this is a maximum value. And that maximum value is the vertex itself at 7, 2. This tells me also something about the range, since this will be the highest point my graph gets and it stays, everything is staying below that. We know that our range is going to be from negative infinity to positive 2 because our range talks about our y values. We also know that we'll be increasing on the left of our graph but decreasing on the right. And the switching point is the x value of our vertex. So increasing from the left from negative infinity to 7 will be increasing, and as soon as we hit that vertex from 7 to infinity, we are now decreasing. A landscaper has enough stone to enclose a rectangular koi pond next to an existing garden wall with 24 feet of stone. If the garden wall forms one side of the rectangle, what is the maximum area the landscaper can enclose? And what dimensions of the koi pond will yield this area? Well, we're not entirely sure what the length is or what the widths are, so we can label them as W, W, and L. But we know that when I add those two W's plus the L together, it has to be 24. Therefore, if we solve for L by subtracting 2W, our L value is now written in terms of W. So when I take length times width, I'll have 24 minus 2W times W. Distributing, I'll have 24W minus 2W. And if I rearrange it, so I'm putting it into quadratic form by having negative 2W squared plus 24W. So putting it from greatest to least, so in descending order. Well, we know then, since this is a negative value, that we're going to end up having a frowny face. So the vertex itself is going to be the maximum value. So let's identify what our maximum value is by identifying what that W value could be. So our A value is -2, and our B value is 24. So opposite of B, so -24 over 2 times our A value of -2 simplifies to 6. So our vertex here is going to be 6 something. Remember, this value here represents the width. And then our Y value, again, will represent the area. So this one will represent the area because that's what we're also looking for as well. I can also find what the length will be because I know what our width is of 6. I can find length by substituting in 6 where I see W and solving. So if my width is 6 and my length is 12, when I multiply them together, I'll get a maximum area value of 72. So 72 square feet will be our maximum area when my length is 12 feet and my width is 6 feet. A model rocket is launched with an initial velocity of 100 feet per second from the top of the hill that is 20 feet high. This gives us the height in feet t seconds after it has been launched by the given function. Determine at which time the rocket will reach its maximum height and find that maximum height. So S of t represents the height and t represents time in seconds. I'll let you take a moment to graph this using Desmos, but when I do, we will find the following. We know it's going to be a U shape because of the -16. It is going to cross the y-axis at the point 0, 20. And this is directly related to where our rocket is launched. So our rocket is launched at this particular point here. Therefore, we're looking for particularly where will it reach its highest point. And again, that would be our vertex. We know our A value is -16, and we know our B value is 100. So when I take opposite of B, so 100, opposite of 100 over 2 times -16, that reduces to -100 over 32, or 3.125 when we actually divide. So far this is 3.125, again, that being our time variable. And then we'll look for the height. To find the height, we will want to substitute in our time, giving -16 times 3.125 squared plus 100 times 3.125 plus 20, providing us with 176.25. So 176.25. We can check if we want, but therefore the maximum height is 176.25 feet, 3.125 seconds after it has been launched from this 20-foot piece. Now think about what this part means. So it was launched 20 feet off the ground. So then this point must relay ground level. So at ground level, how many seconds have passed from the time it was launched to the time it hits ground level? And that's just a little added piece, something to think about. But that concludes our lesson today on analyzing graphs of quadratic functions.